Yeah, we are live,
Fine,
Suparna.
fine. So now let me talk about the session number 3. Okay. So in session number 3, it's basically we are purely diving into semantic models. We are purely deep diving into semantic models. In this, here what you can do, you can see the what is semantic model layer, and followed by how we can design scalable semantic models, how we can optimize the model for Power BI performance and enforcing the model security. This and all here we are able to see. Now let's see adding a measures to Power BI semantic models. See, the first thing is DAX. The first thing is DAX. So the DAX stands for data analysis expressions. So from data they took D, from analysis they took A, from expressions they took X, but I am not sure why they don't pick E. It's their wish because Microsoft is a parent. If I can ask you for your child how you kept that name, that is irrelevant. Like this, they are taking that as a DAX, data analysis expressions. DAX is like it's a library of functions. And if you remember, in our Excel we have different kind of functions in Excel. The similar kind of all expressions which is replicated in the DAX. The all functions which is replicated in the DAX. So here you can see you can build formulas and expressions. You can create calculated measures, tables, columns. Now here you can see this is some sample snapshot of that. You can create new table. You can add new column. You can create new measure, and there is something called quick measure. With the help of quick measure, you can get some suggestions from your data model. You can get some suggestions. Now here you can see how you can create measures. So creating the measures, so as I mentioned earlier, here we have some formula. See in this example, for here they are calculating the profit, which is sum of sales minus sum of cost. So here what they are doing, they are calculating the measure. So this calculator icon is measure. So here it will calculate the result on the fly. On the fly means you will see in subsequent slides. Next, the one good added advantage is this is not stored in data model. This is not stored in data model. So this measure means this calculator icon. Next, it is responsive to interactions and indicated by, as I mentioned, calculator icon. Fine. Now here you can see understanding the this filtering context. So here what happened, I created the total sales measure. I am using column chart here, just simply it is showing this total sales. Now after that what I did, in bar chart I am using total sales in the x-axis and here in the y-axis. So here when I am using this total sales, it is automatically this 1.35 million dollars, it is filtered across 16, 15 and 14. Now again what I did, again I take a one more column chart. In this column chart, in y-axis I have total sales and in x-axis product ID. Now this total 1.35 million is filtered across all the product IDs, across all the product. This is called dynamic. This is called dynamic, and it is depending upon the filters. Depending upon the filters means, let's say instead of here, if I can drag region, according to the region, dynamically it will change. According to the region, dynamically it would change. Now here you can see this is a sample calculate function. This is sample calculate function. So here what happened, they are taking sum of the total price and they are applying the filter to year of 2015. Here what this is total sales, this blue color 1.35, but from that what is the 2015 sales, which is 0.66 million. Here I am filtering the data with the help of calculate. Calculate is a function where you can use multiple filter conditions. Okay, now let's talk about measures. So here you can see semi-additive measures. Measures means here you can create the measures based on the context. Let's say there are 4 countries: US, UK, India and Canada. I would like to see only India data. What I will do, I'll take calculate sum of sales and country equal to India. I will take this like this. And time intelligence measures, you can use time intelligence measures means basically you can use time intelligence measures for trend analysis, like how my sales is last year and how the sales trend is happening this year. And you can use some aggregated functions also. So here you can see last sales quantity for sum of sales, which is last date of order date. Fine. Now let's see, create a common table. See, I hope those who are working as a Power BI developers, they already know. If you are billing, let's say for example, KSR sales. I'll take KSR data vision sales. So in this, if you would like to build some time related analysis with the help of date column, you can separately create a date column. Tim, can you give me just a minute? Fine. Now calendar table, calendar table you can create. Just a minute. Calendar table you can create as a separate dimension just to calculate time intelligence DAX calculations. What is that? Year over year, month on month, quarter on quarter, date on date. So previous year sales, with the help of this calendar table you can calculate that. Now here you can see this is the sample time intelligence DAX functions. Here what they did, they are calculating the total sales for previous month, total sales for previous month. Now here you can see calculate sum of sales previous month. So what happening, it is taking this is here, this 56 is here, 55 is here, this is here, like this it is calculating the previous month sales. Sorry team, I'm getting some cough, please bear with me. Fine. Now let's see, just a minute. Now let's see calculated columns. So in this calculated columns, see the calculated column icon is like this. On top of some, then there is summation symbol. There is some summation symbol. Here you can see it is computed and stored in data model. It means that let's say there is a table, serial number, country. Just a minute. Hmm. So here you can see there is something called serial number, country, and here product name, and here sales, cost, and I'm going to add price column. So if I add, this will be added to your existing table. This will be added to your existing table. So it means that it is storing in my data model and it is increasing the model size. It is increasing the model size and it is recalculated during the data refresh. It is recalculated during the data refresh. Fine. Now let's see others. Now calculated tables. So in this, you can directly create a table. So let's say here with the help of calendar auto, directly I am going and creating a date table. It means that it is creating separate table like this. This is new table. Let's say there is a table called serial number, country, state, city, sales. From this, I would like to create a subset of table. Let's say for example, city wise sales, summarize. For that, we have a beautiful command which is summarize. With the help of summarize DAX function, you can create a subset of table like this. Here it will be added one more table. It will be added one more table. Fine. Next, let's see what is the difference between calculated column versus measures. Now, here you can
Suparna,
see. Uh,
I have a question on these calculated tables. Is it more like what you call summary tables?
yes, No, not summary table. See here in this example, just a minute. Here you can see there is date table. This is essential for performing some time related analysis. After that, here as per this example, I have country, state, city sales, but I need a analysis. For that, I need to see the city wise summarized sales. For that, what I will do, I'll use summarize DAX function. It's, you can take it as a summarized tables or subset of table from your main table. It means that still it is referencing to your main table only. This is my main fact table. From here I am creating one more subset of table for city and sales here.
So the calculated table can be a combination, a join of both the fact and dimension table with aggregation in it. So I'm just trying to see the use case. Is that similar to a materialized view?
Yes, you can take that as a it's a kind of a materialized view. It's a, you can take few columns from fact, you can take few columns from dimension, and you can create it.
Thank you.
Yeah, thank you. Now let's see this one. See the difference between column and measure is, see your calculated columns are, it will be added to your data model, which is nothing but table. Your measures are invisible. Your measures are invisible. It will not affect the model size, but calculated columns increase the model size. Here what it will happen, it will calculate the row by row, but DAX expressions are, it is dynamic expressions. If you drag this DAX measures, it will filter according to that visual. But and here you can see this tax calculated columns, it will store in PBX file, but it is calculated based on the filters. This is very, very important. Next, let's see how you can see the scalable semantic models. See here, there are something they mentioned: massive, complex, diverse, rapid, and valuable. Okay, fine. Now here you can see what is scalability and why it is important. See, whenever if you are going and building any semantic model, so it should be scalable. Scalable means whenever if you are going and filtering anything, if you are applying filters, it should retrieve the data as much as faster. It should retrieve the data as much as faster. So that's how here you can see flexibility. Models need to be able accommodate and change. So based on the data volume or data growth, you can create semantic models. So in future the data is growing, so that semantic model should not be slow. In that case, what you need to do, you can go and implement some, there is a concept called incremental refresh. There is a concept called incremental refresh, and you can reduce the complexity. You can reduce the complexity, like delete unnecessary columns, keep only necessary columns, and use proper data types. Like this you can reduce the complexity of semantic model. Now, here you can
Uh,
see,
Suparna, I've got a question on the fundamentals of semantic model. Previously, we were building semantic models within each Power BI report, right? Now, the semantic model enables us to basically build a common semantic model. So that way, every Power BI report can consume the same semantic model instead of trying to build semantic models within Power BI. Is that the right approach?
yes, you can build on a large scalable semantic model. From there, you can distribute that semantic model to your developers so that they can build their respective dashboards.
Thanks.
Yeah, fine. Sorry, team. Now let's see, these are the some you need to keep in best practices. We will see what are the best practices when we are going and building a semantic model in subsequent slides, and make sure that which mode you are using. See, we have direct query, import, direct link. See, this is new mode. When the fabric was launched, then only we have this mode, direct link mode. And here there is one, while creating your workspace, just now Ajay shown you, while creating workspace, at the bottom here you can see there is something called semantic model storage. We have only two options. One is small semantic model storage, another one is large semantic model storage. So that when you are creating, if you would like to build a scalable semantic model, you can choose this option, semantic model storage. You can choose this option as a semantic model storage. Fine. Now let's see in depth. Now here, choose best storage mode. Now we are in best practices. See there, you all know there are three modes: import, direct query, direct lake. See import modes. What is meant by import mode? It means that you are bringing a copy of data and loading it into Power BI. Loading it into Power BI. It means that you have full control over the data. We have full control over the data. And you can create calculated columns. You can create measures. You can do whatever you want, because already what you did from database, you are imported. Imported means what you are doing. See, in e-commerce, we are seeing somewhere it is import material. Import means what? From America, from Japan, we are importing some electronic goods into India. Once if it is imported, there is nowhere relation to Japan or America. Like that, here what we are doing, we are completely bringing a copy of data into Power BI. This is called import mode. So that's what, as I mentioned, it will support all the transformations and require data refresh, but it need refresh. So if there is a new rows updated in database, what you need to do, you need to set up a gateway. With the help of gateway, you can refresh the data. You can refresh the data. Fine. Now let's see direct query. See, direct query is nothing but, let's assume this is a database. So this is your Power BI. Here you are semantic, you are building it. No. So just here you are referencing the data. Just here you are referencing the data. Here you are not bringing data into Power BI. It means that whenever if you need any requirement, let's say you would like to change a data type, you would like to add a column, you need to rely on some other person. Just a minute. Uh, you need to rely on some other person who is none other than data engineer. Data engineers are the people which will help us for business. BI engineers who is data analyst to getting the required data from them. So for every time, let's say I would like to see one more column. What I will do as a data analyst, I will request boss, I need this column, please add. Once if he added, automatically again it will reflect here. Then I can build my report based on that. So that's what here you can see, connect to the data source and only stores metadata. It will not store actual data. And moreover, one thing is, it will support limited transformations. It will support limited transformations. And it is stay up to date as a source. And DAX functions also, if you come, there are almost lot of DAX functions which will not support in direct query mode. But one thing is, here in import mode, we have the luxury, but import mode, the limitation, one more limitation is we have only some storage constraint. But here we don't have storage constraint. We can bring unlimited data, because we are not storing data into Power BI, just we are pointing it to database. Next, direct click. See, and there is one more thing, if you don't know, that is nothing but composite model. Composite model is a combination of import and direct query. See how you can do this. Let's say I have fact table, uh, one dimension table. Let's say this is country, then this is dimension product. So what I will do, I'll keep this two as a import mode, and I'll bring this as a direct query mode. Now this semantic model, I'll call it as a composite mode, because fact table is a table which is having the actual business information, and it is in terms of storage, it's a large table. Then you come to the dimension table, it's just a lookup table, so that it will have very less amount of data, and I can put this in a import mode. In that case, what will happen? It will act as a composite mode. It will act as a composite mode. Now let's see direct link. This is just recently when the Fabric was announced as a GA. At that time, they were launched this as a direct link. Direct link means it connects to only Fabric Lakehouse. Direct lake will not support any other data sources. It will only support to lakehouse. And as like direct query, it will have a limited transformations, and it will have a limited DAX functions, and but it stay up to the data source. Here also in direct lake mode, what will happen? Let's say there is a fact. here there is one dimension, here there is one dimension, here there is one dimension, here there is one dimension. See, here there are some values, there are some values. See, whenever I am applying any filter on top of the report, so what it will fire a query at the back end. So at that time, based on the processing data volume, based on the processing data value, automatically, let's say this dimension data processes data volume is low, then it will automatically fall into the import mode. Then again, this will be in the direct query mode. So based on the processing data, automatically it will adjust. Automatically it will adjust the import mode and direct query mode. Now, next. Next, see.
Suparna, I've got a question on the composite mode. Now you said we'll keep the fact table on a direct connection and the dimensions in the import mode. What's the advantage of that? Because even the dimensions, they are small, but they will be changing. What's the point in having the dimensions in the import mode and the fact in the direct mode in a composite?
See, in a composite mode, see, we are keeping anyhow that one in the, if you are keeping dimensions in the import mode, if you are keeping dimensions in the import mode, what will happen? Your data retrieval is faster. Your data, when I am applying any filter, any slicer on the report, it will fire a backend query. For fetching the data according to that filter, your direct query will take more time, but your import mode will take less time. So that's what it will consume less amount of time for import mode. For direct query, it will take more amount of time. So that in a combination of this both, let's say those two are in direct query, it will, let's say if it take 5 seconds, for combination of composite mode, which is import and direct query, maybe it may take 3 seconds, maybe it may take 2.5 seconds. The process of timing will reduce.
Thanks.
Yeah, fine. Now let's see what are the some best practices for data modeling. So here you can see, whenever if you have a tables in your database, let's say this is Azure SQL database. Okay, you have some tables. Okay, you have some tables. So the first point what they are mentioning, don't directly connect with your physical table. When I say physical table, it's a created table. If you request, your data engineers will create, let's say, view. This you can take it as a view. You can directly point it to the view, because let's say your physical table which is having 500 KB, if you create the view, almost it should be 50 KB. So view will store less amount of data with the same data, and also in your actual physical table you have 100 columns. That 100 columns is not required for your analysis. You can just request your data engineers to create a view with the selective columns. Let's say out of 100 I need only 70. I can request them to, boss, can you please only view with this 70 plus columns, so that I can consume in my Power BI for reporting. Like that you can only connect with the views instead of tables. That's what they mentioned here. Now include only necessary tables, rows and columns. This is very, 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 very important. See, unnecessarily don't load all the tables. See, wherever if I am seeing in past few of my projects, everyone directly using select star from ABC table. If you use star, it will import all the columns. But do you think really are you going to use that 100 columns? Definitely no. You can bring only selective columns, column name, column name, column name, column name, like that. Select, you can take that how many columns you require from table name. Like this, you can bring only selected columns, selected rows, like this. And this is one important thing, incremental refresh. Let's say as asked by someone, I have 15 years of data, 2015 to let's say 2016, 11, 26, 2000, 11 years of data. Now let me ask you a question. So this is, you can assume Swiggy data. This is, you can assume Swiggy data. I have 11 years. See, can someone answer, am I going to modify my Swiggy order details in 2017? Am I going to modify my order details in Swiggy 2017? Definitely no, because that is already done. It's almost 9 years ago. It's almost 9 years ago. sorry, 7 or 8 years ago. Like this, what I can do from 2015 to, let's say, till 2025 December, 2026 December 31st, I will archive the data. I will archive the data, and I will keep in refresh only 2026 from Jan 1st to till date. With the help of incremental refresh, you can reduce the refreshing time, because that is already historical data that is never going to change. Even though if you are using Amazon also, if you ordered something headset in 2017, now are you going to modify that order? Definitely not. If it is in the recent days, you can return it or you can replace it, then the order status will be changed. The order status will be changed. Now the next concept is partitioning. So the partitioning is like that. You can partition, let's say you have different years of data, you can partition year wise. Usually in real time, the by year we can partition the data. So that's what, with the help of incremental refresh partitioning, we can avoid unnecessary data. We can avoid unnecessary data. Fine. Next you can see here data types. So let's say you have a date column, you are using ABC data type, which is wrong, and it will impact you report performance and semantic model performance. You need to use date data type. For sales, it's a whole number or decimal number. Like this, you need to use the proper data types, which is integer, strings. Next, enable query folding. So when you are connecting any data from database, there is a concept called query folding. What it will do, it will generate a query. It will generate a query, and it will reduce the burden on the Power BI engine. It will reduce the burden on the Power BI engine. Fine. Now that's what, as I mentioned earlier, there is something called as a best practice. You need to enable large semantic model. So this is something, when you are creating the workspace, you can toggle this button. You can toggle this button. See, allow this model grow beyond default up to 10 GB limit. And semantic model sizes are limited only by capacity size, maximum set by the admin. So this is somewhere they will take care of Fabric admin. But this large semantic model storage format need either premium or Fabric capacity workspace. It won't work for Pro. It won't work for Pro. Now let's see incremental refresh. See, here you can see in incremental refresh. So here what's happening? Okay, the same slide. Here incremental refresh. That's what, as I mentioned, first you need to create a parameters in Power Query. There is no other choice. There are some not best practices. It's a mandatory. You need to use range start and range end. You need to use range start and range end. With the help of, you can use the range start. Here what I will do, I can select 2015, and here just a minute, sorry. So here what I will do, here I can select current date, which is 2026. So with the help of this, after that, it will enable a pane in your Power BI desktop. From there, you can specify, I need to archive the last 10 years data. Like this, here you can see here, this is archived. This is archived, and this is import mode, and this is enabled for the refresh. See, here it is refreshing. It is just a some small demo video which is provided by Microsoft. Now here you need to configure the refresh policy. Data refresh change based on the parameters. Whatever the parameters you can change based on, I would like to archive 7 years of data. I would like to refresh only last 1 year data. Like this, it will refresh only last 1 year data. Next, partitioning. So partitioning means you can partition. Like this, I will partition year wise data. So when if I would like to bring the data, just I will call only that 2012 data. I will call only 2025 data, and you can configure this with the help of SSMS or tabulator, and nowadays there is something called TMDL view. With the help of this also you can configure this. Now let's see additional storage mode configurations. Here this is sample snapshot. See, this is just a aggregate. Here you can select this, you can manage the aggregation. Now here you can see there is something called first import direct query. See, this is something called dual. This is something called dual. See, you can directly change this. Let's say if you are data is in the direct query mode, you can change this to import. You can change this to import, but reverse is not possible. Reverse is not possible. This is possible, but reverse is not possible. Once if it is brought the data into your Power BI desktop, now it is not possible to again go back as a direct query. From Power BI desktop, you will find in the model view. You will find this in the model view. Now let's talk about relationships. See here, as you seen in the data warehousing session, we have three type of schemas. Here also we have star, snowflake, and galaxy or bridge schema. See here, what it is showing, there is a fact sales table. It is connecting with product, territory, employee, seller, and dim date. Now here you can see this fact table is connected with dimension table with the relationship. Now let's see the relationship. Here we have many values. That's why it is star. And here only we have lookup table one value. Like this, it will connect like this. Star 1. It means many to 1. Many 1. Many 1. Many 1. Like this, you will get this. So this is also called as a dimensional data modeling. So one fact table surrounded by many dimension table. Now here snowflake schema. Snowflake schema is a schema where this dim product would be connected with another dim table. This dim product would be connected with another dim table. Now let's say galaxy. If you have more than one fact table, there is one more fact table, and this is connected internally with some dimension table. This is called galaxy or bridge schema. Galaxy or bridge schema. Fine. Now here, understanding the model relationship. Here you can please understand. See what's happening in the
Suparna,
video.
a quick one. Can you please go back to the Galaxy model? Can you explain a little bit about the Galaxy model?
See galaxy model, just a minute. This is one fact table. And here there is one more fact table. Okay, there is a dimension, there is a dimension, there is a dimension, there is a dimension, there is a dimension. Now this is connected this is connected this is connected this is connected this. Now here more than one fact table, if you see that, we can call it as a galaxy or bridge schema. And again these two fact tables which is internally connected with via some other dimension table. That's why this dimension table which is acting like a bridge, it is acting like a bridge between these two fact table. That's why this is called it as a galaxy or bridge schema. If you having more than one fact table and that fact tables which is interconnected with the dimension table, that's call it as a galaxy or bridge schema. Rarely it will use in real time, but the standard schemas, star and snowflake schema, they will use.
So it's basically what you are saying is dimensions will connect multiple fact tables, right?
Mm, mm.
That's the Galaxy model. But sometimes we can have basically fact tables which are related as well. Like say for example, um, I've got sales table, sales fact table, which is showing only sales data. Then I've got deliveries fact table, which is showing deliveries, right? And the deliveries are against the sales orders. So now the both the fact tables are also related. Is that what you also call as a galaxy table, or only when the fact tables are related through a dimension is what you call as a galaxy?
No, no. Only fact tables are is connected through a dimension table. As you mentioned, customer table, orders table, there is delivery table. So in between, you definitely you would have a lookup table which is called dimension table. So connection between fact to fact, it's not possible, and it is not a best practice also. It's not a best practice because it will build a many to many relationship. It will give you inconsistent results. To
That's right.
avoid
Yeah.
that, with the help of dimension, we will connect these two facts each other. That I'm calling it as a galaxy or bridge schema.
Yeah. Thank you.
Yeah, fine. Now let's see here what's happening. The understanding of model relationship. Now let me tell you. Here, let's say there is a category dimension. the relationship is one to many here. Then in this product table, we have this category A, this one, category A, category A. Again, next here, the sales of this, what is the common column? 3 and 3 here. So for this 3, here we are getting this 11. So the year dimension is connecting from here to here as a one to many. So finally, when I apply filter category A, which is Jenny Jones, I will get the 11 as a sales for this year. 11 as a sales, because Jenny has a made sales only in this 2018, only in 2018 as a sales as, let's assume $11. Let's assume $11. This is how you need to understand the relationships. Now let's see the relationships. See how you can relationships. This in technical terminology we will call it as a cardinality. You will call it as a cardinality. Now here you can see there are basically 4 type of cardinalities. I think they are included both in one. This is one to many, many to one to one, many to many. So here you can see this is many to one. Whenever if you have many, it should be star. One means one. Now this is filtering direction. So it will filter from this product to sales. It will filter from product to sales. See one to many, single. Many to one, maybe both are single, but this is not recommended one. And one to one, it is always both. And many to many, it is single, both. Ideally, if you use many to many, it will directly take both. But this many to many, you need to avoid in real time. This will give you the inconsistent results. This will give you the inconsistent results, and the relationship also not stable. Relationship also not stable. Fine. Just a minute here. Now here you can see how you can build the relationship from the DAX. You can have few DAX functions which is related table, user relationship, cross filter, combine values, treat as some parent and child functions. With the help of this, you can build the relationship. You can build the relationship. Let's see few examples in the subsequent slides. Now here there is a example. There is a example. Here what happening? The active relationship is order date to date. The see the which is in dotted, it is inactive. Which is in dotted, it is inactive. Which is in the dark thick line, it is active relationship. Which is active relationship, it is inactive relationship. So now here I am getting the order date by sales. Let's say I would like to see the ship date by sales. So for that, here see, that's what first thing they mentioned, sales by order date. This is fine because already we have a active relationship. Now here you can see, if I would like to activate, I mean sales by ship date. So for that you can use this measure, which is nothing but calculate, sorry, total price and user relationship. Here you can mention this calendar date and sales date, and but this measure is only applicable to this visual only. This measure is only applicable to, because here we are activating this relationship for calculating the sales price for only ship date. Only ship date. Okay, fine. Now here understanding the relationship evaluation. So here what you need to do, you need to use some regular relationship, some limited relationship. These are some standard best practices. Okay, fine. Now let's see write a DAX functions. So now here you can see use variables to improve performance and readability. See here, this is the one example. You can see sales YOY growth. Sales YOY growth. See here what they did. They are combined everything. They are combined everything in the one, two lines. See here, if I'm seeing, I myself is confusing. What is this calculate? What is this parallel period? And what is this month? Again, why they are calculating? Again, why they are using again calculate parallel period? This and all this. So it's totally confusing. It's totally confusing. But now here you can see I am going with a year over year. First I am calculating sales prior year. So I am completely bringing this into a one variable called previous year sales. Next I am using one more variable, which is this one. So here what I am doing, sales, this is already default measure sales minus this variable I am calling it here sales minus previous year sales divided by previous year sales, and again I am returning this variable. Now it is looking clean, it is looking clean and understandable. But if you see for the first time, automatically first on the first glance you would be panic, what is this, why are they are repeatedly doing parallel period again and again like this, you will get a panic situation. That's what variables is very helpful to clean, to it's mean for clean way of writing the DAX. Fine. Now next, iterator functions. What is meant by iterator functions? Those DAX functions which is ending with x, which is called iterator. It could be sum x, it could be average x, it could be min x, it could be max x. So this is called iterator functions. See what this iterator function. I'll take you one example. Let's say there is a data customer. There is a let's say cost and sales. So ideally, if I would like to calculate profit, what I will do, I will subtract this with this, so that here I'll get the profit column, but this has a calculated column. This has a calculated column because I don't want to overburden my data model. I would like to do it in my DAX measure. So what I will do, I will take sum x, I will call table name, then I will subtract sales expression minus cost. So here what will happen, it will go and it will calculate row by row, it will calculate row by row, it will give you the exact same result whatever I did with the help of calculated column. This is called sum x. Here also see they are mentioned same row by row calculation with the single value. Here what they are doing, they are calculating the total profit, which is sales quantity into sales minus cost, sales quantity into sales minus cost. So here it will help you to calculate the row by row calculations, and no need to add the any calculated columns, no need to add the any calculated columns. Next, this is a just example of sample table filtering functions. Here you can see with the help of calculate table. Now I would like to see only 20 financial year 2018 sales, financial year 2018 sales. So here what's happening, here you are getting this sales, but when I am dragging, it is showing this sales here. But here, if I am applying in this screen, here I am getting the 16,429 sales with the help of this sum x and calculate table. So basically, calculate, calculate table and filter, these are the table level filtering functions. These are the table level filtering functions. Now let's talk about window functions, which is my favorite functions wherever it is in SQL or Power BI. So as like you have rank, row number, dense rank, here also we have that kind of thing, but here that is something called offset. You need to use the offset. See here, let's understand this one. See, you can get the previous year sales with the help of parallel period or same period last year, but here with the help of window function, you can specify the window of the data, and it is useful for ranking and running totals. Here what they did, calculate total sales offset, they are giving the -1. You need to go to the -1 and order by year ascending. So here what happening, it is going to the one step below -1. So -1, so I mean for previous year sales. So it is going, so it is calculating 18 here, 19 here, 20 here. See, what if I would like to see the 2-year sales, then in that case it would come here, it would come here. So here what we can do, we can specify the window. You can specify 1, -2, -3. What if I would like to see the future sales, instead of minus, you can just specify 1, then in that case it would go here, it would go here, it would go here. Like this, your window functions are also very useful. Just here they given only offset. There are some row number, there are some other DAX functions which is already available in our NDAC YouTube channel. So this Ajay will share the link, please go through that. Now next, there are some informative DAX functions. So
Suparna,
informative,
I have one question on the previous. Yeah. So when we are using offset -1, right? Just we are getting the same date last year sales, right? Let's say I wanted to get the same day, like today is Saturday, right? I need to get the same like last year Saturday sales. So is that possible using this window function?
Here, instead of year, you can use date.
Oh, yeah. Okay.
Yes. Yeah, fine. Now let's talk about informative functions. So here the informative functions, it will just for some checks and conditional resulting values. Here you can use with the if control. So here you can see there is something called total sales for single category. It means that here for product category sales, so sum of sales and blank. So here total sum of sales means here what it is getting, I am getting the total sales. So I am telling that you can give total sales as a blank. That's why here if I am using the same measure, here I am getting the blank, and for the regular column I am getting the value. So this is what some informative or information functions. Now let's see some dynamic calculation elements. See, there are some concept called calculation groups. There are some concept called calculation groups. With the help of these calculation groups, so ideally there is year column, and here you would like to show year over year, month on month, quarter on quarter, and previous year sales and year over year growth. Let's say what you will do, you will create this one measure, this one measure, this one measure, this one measure. But instead of creating multiple measures, or instead of creating multiple values into the table chart, you can use this all measures into something called calculation groups, CG, which is calculation group. You can calculate it. You can directly use that calculation group in this visual. It will populate all the columns which is defined in the calculation groups. This is very, very helpful and reusable. Basically, this would be using in matrix visual, or we can use it in table chart also. Fine. See, this is the sample calculation groups measure. Now field parameters, which is very, very interesting topic and my favorite option in the Power BI. So here you can see field parameters is a concept. Let's say the requirement is, here I have total sales. So my client is asking to show the charts, total sales by category, total sales by color, total sales by product. So what I need to do, I need to build 3 charts, because the requirement is total sales by category, total sales by color, total sales by product. So instead of going and using multiple charts, killing the space of the Power BI canvas, you can create the parameter. And once if you create the parameter, you can get the parameter slicer here, and later you can use the same parameter here, and later you can share this with your boss, your client. You can tell them, boss, you can choose whatever you want. You would like to see the category, then here it would change dynamically. If I select color, it would change to the total sales by color. Like these field parameters, it will be very, very helpful. And there are 2 types. One is numeric range parameter, one is field parameters, which is categorical parameters. Numeric range and this categorical field parameters. Numeric range, it would help you to dynamically switch between the for top and bottom 10 customers, but this is based on the selections. Fine. Now next.
So Suparna, the field parameters basically enable us to dynamically switch the axis dimension.
Yes.
Right?
Yes. See here, you can see in category, currently the selected value is category. The moment you select product, it will change this category to the product.
Yeah.
Fine.
And
now,
one more thing,
yes.
coming to the parameters, the purpose of parameters more abundantly. When we are using more columns, for example, if we take matrix chart or a table chart, when we have more columns, rather than increasing the length of that chart, having the horizontal scroll bar, we can use these parameters flexibly. The client can use the selected categories. They can go with the selected categories for fetching the report.
Yes. Great. Thanks for adding that. That is also valid point.
Yeah, thank you.
Yeah, thank you. Now let's see some dynamic formatting settings. See, let me tell you, if you are using any matrix chart, let's say this is country. Okay, this is sales. Sorry, just a minute. Uh, iterator functions. Where are we? Oh, let me open this. Okay, now here you can see country. Let me put this here. Country, sales, profit. So what will happen? Let's say India. See 1 crore. I will put zeros here. 50 lakhs profit. Let's assume 50 lakhs. Okay. But instead of showing this many zeros, you can directly go and show millions, thousands, billions, and trillions. This is one of the best practice, very widely used in the real time. Let me show you the example. See here, there is a measure with the help of switch measure. What they did, if the sales is greater than 10 lakhs, this is some standard format where this you will get it from MS documentation, Microsoft documentation. You can concatenate this with the M. You can concatenate this with them. If the sales is greater than 1000, you can concatenate with the K. If the condition is false, the two condition is, then you can show it as a zeros. Now let me show you the example. See, this is the example. See how first total sales is, now how it is. See here it is showing. See, for bikes even it is, I'm struggling to read this. I think 6 crore 40 lakhs 69,033. But here I can read easily 64 million, 539K, 2 million, 11 million. And here see the total sales itself 7 crore 75 lakhs. But here I can read easily 78 million. So it is very, very widely used in real time. So this is also very important for your certification point of view. Now, let's talk about optimizing the data model. See, here you can see there are data sources, models, visualizations, and environments. See, in Power BI, Semantic Model or Power BI Desktop, you have something tool, there is a called Performance Analyzer. So what you can do with this Performance Analyzer, you can first start recording and you can apply some filter. Based on that filter, let's say there is a chart, sales and profit margin by month. In this, for rendering the DAX query took 19 ms. Ms means milliseconds. Visual display 28 milliseconds. For others means it should depend upon your internet speed, your system RAM speed, and everything. Like this, you will get, with the help of performance analyzer, you can tune the performance of your semantic model and Power BI report. See, this is one of the very good best example. Here you can see I am calculating the count of customers, distinct count, and filter. Here I am going to calculate only the order count of customer greater than or equal to 5. So now here you can see filter. So if I am using filter, it is taking how much time? See, and if I am using keep filter, it is, see how much time it is taking. Only just a 54 seconds for DAX query. Here it is taking 2754 milliseconds. That's what you need. This is where your optimization will come into the picture. Fine. Now let's see create and manage assets. Okay, here that's what, as asked someone, we can create one centralized semantic model and you can publish that into the workspace. From there you can pull the semantic model as a Power BI semantic model and you can build the report however you like. That's what this is called, Power BI reusable assets, which is Power BI semantic models. Power BI semantic models. So now here you can see, here we have, there are new some, previously we have just dot PBIX formats, but recently we have PBIP, which is report format, and there is something called directly you can use TMDL view. With the help of that, you can directly copy the script of your entire semantic model. Now tracking and see, that's what, if you are using reporting format, with the help of, if you are good at coding, so with the help of Visual Studio, you can track the changes. Like in your GitHub, if you are a data engineer, you will know that whatever the changes, we can compare. Once if the changes is good, we can commit to the main branch or feature branch. Now next, let's talk about deployment pipelines. So now here you can see deployment pipelines. See, deployment pipelines is a workload where you can push your changes from one environment to another environment. Ideally, we have dev, UAT, prod, UAT prod. So you are developing. What you can do, you will publish this into the dev. Later, you can deploy to UAT. Here, end users are like your client will test it. If there is any change, again you can implement, again you can publish, again you can deploy, again they given sign off, directly you can deploy it to the production. From there your end users will consume the report. See, this is a sample snapshot. This is a sample snapshot. So here you can see test file 2. This is not there in the previous stage. This is not there in the previous stage. Now I'll select here, directly I'll click this deploy button. Fine.
Suparna,
Yes.
now these deployment pipelines,
Hmm.
do they apply to all Fabric objects like data lake objects, Synapse, the actual Fabric pipelines, all of these,
No, no,
and
as of
semantic
now,
models?
it is supporting to many of the objects, but there are some limitations for few objects, but not yet fully functional. Not for all the workloads, it is not supporting, but it is supporting to the, as of now, I know Lakehouse, Warehouse, Semantic Model, Data Flow, Gen 1, Gen 2, and there are some limitations. We need to go through that documentations. What are the supported workloads and what are non-supported workloads?
And
For this, we okay.
and similar to Power BI,
Hmm.
in Power BI, we have got dev, QA, prod, right? Now, say, for example, I've gone made changes in dev to some objects like semantic models, reports, etc., and I go into QA. It
Hmm.
basically shows me what is the difference between QA and dev and lets
Hmm.
me select those objects and import them into QA. Will it be the same approach here in the Fabric deployment pipelines?
Yes, yes, exactly the same approach. It will show you the difference.
Suparna, like we need premium license, right, for this?
Yes, premium license means, I'll tell you, good question. Deployment pipelines will work only premium workspace. Your workspace should be assigned to either premium per user or premium capacity or fabric capacity. For pro, it will not work. For pro workspace, it will not work. Only PPU, premium capacity and fabric capacity, it will work. Fine, thanks. Now let's see. This is endorsement is nothing, but you may expect one question from the exam. They will ask, see, usually in real time, what will happen? They will build some centralized data semantic models. They will endorse like this. See, certified. Certified means you can share this with your developers, and it meets your organizational criteria. How they will ask, in exam, they will give this line. As part of endorsement, certify your semantic model to show co-workers that has been reviewed and meet your organizations. And what could be the this endorsement? They will give this as a, this as a B, this as a C, this as a D. Then that's what you can read this for. This already available in your documentation. No need to share this slide, or else you can take the screenshot. Based on that, you can choose the answer. Here the answer is C. Like this, you will get it. Basically, how this would helpful, they will endorse. And here you can see there is something called master data. If you created a centralized semantic model, so what you can call, you can endorse this as a master data. So by seeing this in the workspace, your developers will know that, okay, this is a master data. Okay, from this I can pull this into my Power BI. I can build the reporting as per my requirement. Like this, you can specify this endorsement in the semantic models in the, but this is your fabric admin need to enable this in the admin settings. Now, here you can see there is something called lineage view. So the lineage view is nothing but how your report is built. See, we will come from front to back. This is front end. This is back end. Okay. First, sales report. Sales report is made on top of the sales analysis semantic model. And how this sales semantic model is created? So this is gateway, and there is one file is CSV, one file is CSV, and another file is SQL server. Another file is SQL server. So like this here, this is HTML file. This is HTML, this is CSV, this is with the help of 3 different sources. I created a semantic model. On top of that, I built a report mode. So this in your workspace, you will see first by default, it would be selected. So if you would like to see the lineage view, you need to choose this green dots icon, this green dots lineage icon. Now let's see manage Power BI semantic.
Suparna,
Oh.
now just going back to the lineage analysis,
Hmm.
if I have built an analytic model based on a bronze, silver, gold architecture, and then on top of it, I've got on top of the gold, I've got a semantic model and then a Power BI report. If I go and do lineage analysis, it is going to show me all the tracing back the complete hierarchy.
Yes, yes, it will show. It will show all the complete tracing back hierarchy.
Cool. Thanks.
Yeah. So there is something called XML endpoint. With the help of this, you can refresh the individual components, and you can do the some automation with the help of best practice analyzer. Fine. Now let's see security. Security, you already know we can implement RLS or OLS. See here, you can see there are some different type of restrictions. One is defining the rules, one is schema principles, and one is validating the rules. One is single sign-on. For direct query, if your report is built on the direct query, you can enable the single sign-on, but this is applicable to only selected databases only, not for all the databases. It is applicable to only selected databases. You can enable this single sign-on. Now let's see, this is the sample configuration of this row level security. It's just a static method. Here what they are doing, department equal to game, that's all. There is nothing is there. But here you can see this is dynamic. We have a beautiful DAX function which is called user principal name. Let's say I log in with my email ID. Automatically for me, whatever the region assigned, I can see that my login. For let's say for Gopi, he can able to see the his login like this. With the help of this dynamic row level security, we can see this. See, and one more thing. So there is one more thing, object level security. See here, you can apply object level security on column, on table, either it could be anything. So let's say you have one table, customer, sales, credit card number, and you can assume it will never happen, credit card pin number. So just you would like to share this table with your junior developer. What you need to do, you need enforce OLS on these two columns, and you can enable for this. But this we can do it two ways. One is tabular editor. The another one is there is a new update with the help of TMDL view. We can create OLS directly itself in the Power BI. There is no need to depend on the tabular editor. This is a third party tool. This is a third party rule. But the limitation is you cannot mix RLS and OLS. You need to create separate roles. You cannot mix RLS and OLS. For RLS, you can create one role. For OLS, you can create another role. Now, these are the some good modeling practices. Just please follow this all the practices. Now, so that's end of this presentation. Now I am opening the floor for any questions.